better compliances with regulations. So this is also very important aspect now under the Paris agreement. All the industries across the globe, they have to be very much compliant to the regulations. Like they should use the water and this carbon emission they have to do within a limit. And every country has a mandate that they would be carbon neutral, carbon zero emission by some date. Like in India, the India has a target of by 2070 it should be totally carbon free. So by for like solving these problems, or for uh, properly handling these problems, we need data to get the information. But how should we get the data? So that is one question. And this is a very valid statement that power lies in accurate information driven from real time data. So all these things can be done, all the problem statement can be handled if we have the right data at the right time. So there are some typical monitoring use cases across the industry, whether it is oil and gas, it is clothing and textile, electronics, metal manufacturing, wood, leather and paper, fabric, chemical, automobile. So whatever industry we talk about, they are typically having these kind of monitoring use cases. They have these problems. Like every industry has to do energy monitoring, they have to do temperature and humidity monitoring, ambient air quality monitoring, flow meter reading, water management, predictive maintenance, and other parameters reading like temperature, pressure, flow, current, voltage, etc. So these monitoring problem statements are common across the industries. Whatever industry you take, every every industry would be having these kind of use cases where they need some kind of solution. And these problem statements are generally not a part of process automation. They generally have to be deployed separately. So from the previous slide, I think most of the things you are already aware. I want to emphasize 2 points. One is the water management, and another is the carbon emission, because those are the things that would be coming soon by government of India, and even all the countries' government, to the respective industries to control usage of water and other natural resources. So, like for example, Google has set a new water target by 2021 that it would replenish 120% of water it consumes across its offices and data centers. So this is each and every industry the same way they are trying to control the water consumption. And similarly, we have other green goals, carbon footprint monitoring. So here, India has planned to be the carbon emission net zero by 2070. So there are some steps that they have to follow. I will not go through, but every country has to be carbon free, and it can be done when each and every industry has to follow the norms given by the respective government. Now we come to the digital transformation. So when we talk about industry 4.0, it is basically a digital transformation. So if we look into this picture, the left hand side is the traditional model that has been happening since last 50 years. And the right hand side, we have the industry 4.0 model, where we are moving from traditional to the latest one. So in traditional one, where it is called ISA 95, here basically the control system and the IT system was properly separated, keeping the security in mind. So the lowest level, we have a field level machinery or the sensors, where we have sensor, actuator, and hardwares. And then the next level is the control level, where it is controlling all these parts. And here we are having DCS, PLC. Then we have a process level thing, where we have SCADA and APC. Then the above layer is planning level, where we have manufacturing efficiency system and operational management. Then the top level is the ERP system where the top manager used to sit, and they have the visibility across all the levels. So this was the old way of functioning. The new way of functioning where the OT and IT would coexist, and from each and every sensor actuator level also we can get data and take it to the cloud. So that is the way industry 4.0 will work, and we can control at each inventory level, each machine level, at each part level, that what kind of power consumption is happening and how much efficiency it is giving. So it would help us to better control or better a- achieve the targets for the carbon emission. So that is the way industries are working right now. Even in India we are getting lot of queries to have this kind of, because whatever process control they are having right now in the industries, those are like giving the information or the monitoring at a very broad level. Now they want to have at each and every part level monitoring. So that kind of solution can be provided by IoT, and when we have industry 4.0 model. So these are the problem statements that our industries are facing when they are adopting the digital transformation. So cost of the solutions. So the solutions are little bit costly. The time consuming. Existing infrastructure is not designed for IoT applications. Installation and commissioning of new system is challenging. SCADA software are more expensive as compared to IoT platform. Upgradation without suffering downtime. So these are the typical problems, because we the industries that have been operating with the machines, they are using the legacy systems, and if we have to upgrade them without like stopping them, we have to upgrade, and that is one of the challenge that we have. And this is the general architecture for data uh, collection. So I see that slides are not properly visible. Anybody can see? Uh, so if slides are not properly visible, I have no idea. Probably you, if there is a problem with a single person, then it could be a network issue. If more people are facing a problem, please raise your hands, or please write in the comment box. Let me check once. Okay, slide is visible then. Okay, so let me continue then. I think slide is fine. So here, this is the generic architecture for data collection. Basically, we have multiple machinery, sensors, equipments like pump, compressor, turbines, from where we have to get different kind of data like temperature, vibration, acoustic, or some touch screen, touch signal, or different kind of signals that we have to capture, and we have to bring it to the gateway at one common place, and then we have to send it to the database. Database can be local database, or it could be on the cloud. So the data from machinery or the equipments to bring it to the gateway, we have two options. One could be wired, or other could be wireless. So if you have it is close by, then wired solution is fine. But if the field devices are little far, like sometimes the devices are 1 kilometer range, 500-meter range, then laying down the wire is very clumsy. It is very tough work. So we have to have a solution sometimes that can work wireless. And for scaling up also, if we have wired solution, then scaling up would be very much difficult. So we need to have alternate solution for the wireless in compared to wireline. So now we would be having, or we would be discussing about the wireless solutions, wireless networks. Our topic today is LoRaWAN, and that is the wireless network. So we have to, first of all, we have to understand why the wireless solutions are alternate for the wireline, what kind of problems we have with the wireless wireline solutions, and what kind of flexibility advantage the wireless solutions gives. So here it is very flexible within the reception area. If we use wireless, we need not to worry, we need not to pre-plan everything. If it is wireline, we have to pre-plan that how the wiring would be done. So in case you are scaling up, and if you have wireless solution, it is very easy to deploy. Then we can have ad hoc network without previous planning. No wiring difficulties. Generally, if we have wiring, then historical building, firewalls, these kind of things we have to take care. And it is very much robust against the disaster like earthquake, fire, or anything. The wireless network are more robust. And if we draw to better understanding how in the wireless technologies, which technology is fitting at what level, we have plot we have made a plot here, and on the x-axis we have range, and the y-axis we have power consumption. So we want to see with respect to range what kind of power consumption happens. So when we are talking about the IoT solution and industrial applications, we have to very careful about the power consumption also, because power is very critical resource, and sometimes for monitoring purpose we have to conserve the power. So if we talk about, if we less range and low power consumption, we can place Bluetooth and Zigbee in this place. And if we talk about low range and little higher power consumption, then Wi-Fi would be placed here. High range and higher power consumption, then we can talk about the cellular technologies. And there is one place left where we can have higher range and low power consumption. This is the place where most of the application, the industrial applications, are requiring the technology that can fit in this area. Like we can have higher range, the signal can be transmitted at a longer distance, and the same time power consumption should be as low as possible. So which technology can fit into this? So here, that is called LPWAN, low power wide area network. And here there are multiple different ways we can do. One is the Sigfox, LoRa, and LTE. NB-IoT is also comes under this part. So this is low power wide area network. So if we talk about low power wide area network, it can have thousands of nodes per gateway. It would be having star topology, very small frame payload. We cannot send very huge data. It is used only for the controlling and the monitoring purpose. We cannot do streaming and other things. And it is number of frames per day. We can send limited number of frames, like up to 10. Duty cycle are limited. And we have low bandwidth. Packet loss can be higher, and it is asymmetric, like uplink and downlink. We can have asymmetric data. Sometimes we are doing the monitoring operations. So monitoring is the sensors have to send data to the gateway. So uplink, mostly the traffic would be uplink side, and controlling would be very rare. So the traffic is asymmetric. That is called asymmetric traffic, uplink and downlink. Or sometimes it is unidirectional. If it is only the monitoring purpose, then it would be unidirectional, uplink side, from sensor to the server side. And this is the differences between LoRaWAN, Sigfox, and NB-IoT. Basically, I will not take much time because we have other things to cover. We can share this slide. So typically, LoRaWAN is up to 5 to 15 kilometers theoretically. We have achieved 3 kilometers line of sight so far in our applications, because we are working. And the power, you can see that it is very low, and it is secured. LoRa is secured also. If we talk about the frequency band, you know that right now there is a bidding happening for the 5G band, but that is paid spectrum. But LoRaWAN, the beauty of LoRa is that it is free. It comes under ISM, industrial, scientific, and medical purpose. So there are few frequency bands that are made free by respective governments. So in India, we have 867 megahertz frequency band for LoRa application. It is called ISM band. And these are the different features for LoRa. It is long range, low power. LoRa, the full form of LoRa is long range basically, and then low power, it is multi usage and low cost. There are multiple industrial monitoring use cases. Like we have factory environment monitoring, machine monitoring and predictive maintenance, machine automation, MES integration, production traceability, equipment monitoring and optimization. So there are multiple use cases in industries we have covered, because today's focus was industrial domain only. So we have covered that much. But LoRa has multiple other applications also other than industrial. It has in smart cities, smart agriculture, logistics, so many other applications also it has. So this was the thing that I wanted to cover. Now the next section would be taken by my colleague Mr. Rishabh, and he would explain you about the other LoRa deployment features and the solutions provided by UniConverge technologies. Over to you, Rishabh. uh, Somebody has to make you presenter.
Okay. Thank you, Kaushal sir. Am I audible? Yes, I think I'm audible. So I'm not able to share my screen.
वो तुमको presenter बना दिया?
I think my screen is now visible to everyone. Okay. So as Kaushal sir has already explained you about the use cases and the about the digital transformation and what the key role LoRaWAN is playing. So now I will move to like how we can implement LoRaWAN in our industries, in our use cases. So first of all, why smart industries need a LoRaWAN network? Like why we need a we already have Ethernet network, we already have other networks also, we already have cellular network. So why we need LoRaWAN network? So I have a video that will go through what are the LoRaWAN network and the applications. So you can just watch the video and then I will explain all the terms.
Public, private, and hybrid networks. You choose the network that suits your purpose. Private networks are ideal for large IoT use cases and remote locations. Implement them where you want them, when you want them. Deploy and manage them yourself or hire a third party. You control the network traffic. It's easy to start with one application, scale the solution, add additional IoT applications to the same network, and maximize ROI potential. If your priority is speed to market, or you do not have a technical team, public networks offer a convenient means to immediately deploy IoT. The network operator manages development and deployment. LoRaWAN public network operators offer coverage around the globe. Regardless of technical skills or resources, anyone can implement IoT on a public LoRaWAN network. What about sensors that move out of range of a public or private network? A hybrid network creates an opportunity for connectivity when a sensor is moving from point A to point B between private and public networks. When using both private and public networks, you can not only track an asset's location, but while it is moving, you can track its temperature, moisture level, or other sensor data you need. When you implement LoRaWAN, you ensure that your business is agile today and in the future. Implement IoT in any way that you can imagine.
Okay, so from the video, you got a glimpse that how LoRaWAN can be implemented. So what are the differentiators and the benefits of LoRaWAN network? So first is like we can implement a public network, like some of the uh, service provider are deploying, and we can also deploy a private network. Like if we want a very specific network for our use case, and or we don't have a public network access, then we can deploy our own network. The another good advantage is like it supports firmware over the air update, so even we can update our devices to match all the current specific requirement regarding service and other norms. Also, it supports geolocation. It has a bidirectional security from both on the network side also and the application side also. And now the most important part of LoRaWAN is like it is very low power consumption. Like it can last up to 10 years on a battery. More realistically, it can last up with a decent amount of data transmission. It can easily last up to 2 to 3 years. But yes, if we have a specific requirement, it can last up to 10 years. Another big advantage is like it has a very good coverage area. Like it has a very long range. Like a single gateway can cover up to a good range of 5 kilometers in radius, or theoretically it can cover 10, but under real life scenarios it can cover around 4 kilometers, 5 kilometers of a radius. So it is good for rural areas or the areas where the cellular network is not very good and often doesn't provide a very good connectivity. Also, it have a very deep penetration. Like it has a very robust system because it works on IS sub gigahertz, so it is very immune to noises. So it has a very deep penetration through concrete, steel, and all the buildings, trees. This makes it a very good useful for in the even in the urban environment. Like even for the smart city applications, the LoRaWAN is a very ideal solution. So why industries need a LoRaWAN network? So first, it is very easy to set up, and it helps in deploying monitoring and control systems. We can monitor devices very easily because it has a very long range, and we don't need a lot of cabling need to be done for the devices because often devices are battery powered or solar powered, so we don't even need a cabling for the also. And the data communication is already wireless, and it has a very good coverage in a harsh industrial environment due to its LoRa and chip spread spectrum CSS method. And also it is in a sub gigahertz band, so it has very low degradation in signal, and it is very low powered. It can be used in a battery powered scenario where I can put a sensor and it will easily last me for 2 years to 3 years. So next, why we need a private LoRaWAN network? Some people say like already we will have a private network. Why public network? Sorry, why we need a private network? So private network for the industry is like you will have all your control of data on your own premises, and you will be having a high duty cycle availability as compared to public LoRaWAN network because they are It is specific for your devices only, and your devices only be on the network, so there will be low traffic, and it will be easy to manage and troubleshoot, because you own all the gateways and the servers, so you can easily troubleshoot it. And it is secure because again you have more control over the network, and there will be low operation cost, because now you don't have to pay for the services that are rendered by the public LoRaWAN network providers. So then in the long run, it will be a very low cost of effective solution. Like it will be a very cost effective solution. So here is the industrial LoRaWAN architecture. Here you can see we have a multiple processes. Let's say I have a process one, another process is process two, and another process is process three. Like here we have deployed some energy monitoring solutions. Here I'm monitoring some of the water consumption, flow meter reading, these kind of example. Here I'm doing condition monitoring of our assets. So like these can connect to gateways. So we can on premises we can have one gateways, two gateways, indoor gateways and outdoors gateway, depending on our use cases. But mostly for our industry, which is like a 1 kilometer or 2 kilometer in radius, two or three gateways are far more enough. And then we will only have one network server, and all these gateways will be connected to one network server. And then we can have different application, like we can have our EMS dashboard, we can have our flow meter dashboard, and now we can have our condition monitoring dashboard. So all the application can run separately. The beauty of LoRaWAN is like it can handle thousands of nodes, so like thousands of devices can be added easily. So the scalability is really good. So here are the some key major players who make LoRaWAN devices and sensor for industrial uses. So Advantech, Emotion, ABB, Honeywell, Mileside, Radio Bridge, Yokogawa, Ursalink. They are the like major players who make devices for LoRaWAN purpose, and they provide us industrial solutions. There are many who provide commercial solutions also, but these are the players who mainly focuses on the industrial implementation of the site. Now we will need a gateway. So gateway, there are major companies like Advantech, Techlytic, Cisco, Curlink, Multitech, and Milesite. They are the gateway providers. So they provide gateways out for the system. And next we need a network server. So there are a lot of companies who provide a paid as well as free LoRaWAN network server. Like AWS have a complete managed service. LoRa IoT Curling also provides. Cisco already have a LoRa network server, and then Actility also provide the TTN Things network is an open network for public users, and Chipset it is also a free network. It is an open source, like you can manage your own network. So here is a traditional data creation model and delivery system, which is can be enhanced by a LoRaWAN. So first, if we can see, this is the standard architecture of any current organization or industry. On the ground level, we have sensors, like they can be wired or wireless sensors, like they can work on wireless heart or these kind of thing, and they will require all these wires, scaling, cable ducting, these kind of thing need to be done. Like we have to do a lot of groundwork for putting wired sensors. Then these sensors can connect to a RTU or a PLC, and then here we have a PLC and DCS systems. So the systems which controls the process, and on the top of this process system we have a field and plant networking, the backbone of the networking, maybe our RS-45 networks, our Ethernet networks, our optical fiber network. These are the network backbones. Here we will have industrial switches, routers, these kind of things. Then we will have a SCADA system. So SCADA will be ABB, Schneider, Honeywell, Siemens. These SCADA systems we will be using for controlling and monitoring our plant. And from here, these two are the new things. Like from there we can acquire data, and we can move to these cloud services for our data storage and management, and IoT connectivity like Google Cloud, Microsoft Azure, AWS, and there are several many more in the list. And then we will have the applications for the specific use cases. Like we can have SAP, we can have Aveva, we can have ThinkWorks, and lot of the other applications based on the user requirement. So how LoRaWAN is helping here? Like we can do some of the sensors and make them wireless, like some of the remote sensors or some of the sensors that are not utilized by the process control, but still we need data, and they are not planned earlier in the commissioning of the plant. We can place the sensors via using LoRaWAN network. So LoRaWAN network can be connect to net straight away to the plant field network. They it can connect to the SCADA network also, or LoRaWAN can directly connect to the data lake. Like the LoRaWAN network can directly connect to a cloud service, and they can send data to cloud. So they can be implemented on all these three layers. Here how we can accelerate the adoption of the LoRaWAN technology using traditional sensors. Like we already very familiar and industry, we very much use all these 4 to 20 milliamp sensors, 0 to 10 volt sensors a lot. Like, and also thermocouples RTD, we use them a lot. All, and apart from this, RS45 is a very common interface for connecting from meters, drives, and all these solutions. So from here, we can utilize some of LoRaWAN converter devices or LoRaWAN end nodes, which can take data to a LoRaWAN gateway. And then this LoRaWAN gateway can send data to both public network if we want to send data on public, and it can also send the data on our cloud premises network, where we can run any of the applications or our dashboards, insight applications, analytics engine, and can monitor our industrial plant. So here, how to deploy a LoRaWAN network. So what are the considerations? Here is a compilation that what a consideration is needed for the LoRaWAN network to be deployed. So these are the parameters I will be explaining in detail in the next slide. So this is how you can deploy a network. So first thing is like how to select a sensor node, like the major like what device you will need. So either you will be monitoring temperature, humidity, pressure, flow, RS45 devices, 4 to 20 or 0 to 10 volt DC signals. So you need a device for that. Either you can get a custom sensor that sends data on the LoRaWAN net or alone, or you can put a traditional sensor and convert into LoRaWAN using LoRaWAN converters. Another thing is like what is the sample time, because Kaushal sir already told us that LoRaWAN is not for high speed data connectivity. It has a very limited amount of payload, and it has a very low duty cycle. So we cannot send data very fast. Like it cannot be like seconds time, or like it cannot be like in a millisecond, but definitely we can send data at like a regular interval of 10 seconds, 20 seconds, 50 seconds, but it is more good for systems where we need data in like a maybe in 30 seconds, 50 seconds, or in a minute. Or for battery use cases, this can go up to like 10 minutes, 20 minutes, 30 minutes, or even it can only send the alarm signals when something goes beyond the range. Another thing is like power consumption, because LoRa have a very low power consumption. So it most of the devices can be battery powered. Some of the very remote devices can be solar powered, where the power is not available. And other devices, if we have wall power, then we can power them from our wall outlet. Another thing is range. Like what will be the range? So LoRaWAN can easily cover up to 10 kilometers depending on the data rate we want and the network we are using. So here is a comparison that we already seen in the Kaushal sir explanation. He explained about that how LoRaWAN bridge the gap between the low bandwidth and the long range, and also low power and the long range. So this is a comparison between wireless HART, which is a very usable technology in the industry, to a LoRaWAN network. So here you can see this yellow circle is a LoRaWAN network. So it is a 5 kilometers area covered. And here in a plant, you can see this is a very small network that is controlled by individual processes that are controlled by wireless HART. So these technologies can coexist. Like if we have very high data rate, low latency system that can be communicated via wireless HART, and if we have uh, remote sensors that can have a low data rate that can be controlled to low LPWAN standard like LoRaWAN. So both can coexist on a same plant. So here you can see like it can go up to 10 kilometers of a radius, 10 kilometers or radius. So here we can put sensors in the industry, like a far node and a remote IO can be also sensed. And the another important criteria is that what will be the data security. Like if we are sending data on LoRaWAN or wireless network, how can we secure our data? So LoRaWAN is a very secure network. It has two AES 128-bit encryptions. So it uses application key which separates application uh, to devices, and also it has a network key to provide a set security on the network services. So network and uh, person cannot have the data of your devices. They will need an application service cannot sniff into network services. Here is an example like on from nodes, the node to network server, AES 120 network key, one AES 128-bit network key is used. And for the node to application server, AES 128-bit is used, and it's the application key. So it uses two keys to secure our data. So LoRaWAN network is very highly secured. So any questions so far? If you have any questions or doubt, you can just put on the Q&A session. And now at UniConverge, what we provide, like we provide you with the complete solutions. Like we are the IoT product company, so we provide all range of remote IOs, wireless IOs, LoRaWAN sensors, converters, gateways, a complete LoRaWAN product lineup. So we provide industrial IoT products also, and we also provide industrial IoT solutions. So we provide solutions like energy monitoring, predictive maintenance, remote monitoring, process optimization, sustainability solutions. These kind of solutions we provide to industries, and also we do OEM services. So like we provide solutions for IoT devices, and we design and manufacture IoT devices as per the requirement of the customers. And, okay. And now we provide end-to-end LoRaWAN solutions. So we have energy monitoring solution, we have smart irrigation solutions, smart streetlight solutions we also provide, along with water and flow meter reading, remote meter reading. We also have solution for remote meter readings, temperature humidity monitoring solutions. So we have predictive maintenance and condition monitoring using LoRaWAN. We also provide an industrial LoRaWAN IO monitoring. Also, we give the solutions. What is in how we do environment monitoring? So environment monitoring is like temperature, humidity monitoring of the storage spaces, air quality monitoring, because nowadays the compliances are getting more stringent and stringent, and more people are wanting to like get all these parameter data. Also monitoring of gases like CO2, VOC, ammonia, and etc. Monitoring of the both the workplaces, people are wanting to like manage the workplace also, on the storage like on the warehouse also they want to monitor. So here is the architecture, like how we can do environment monitoring using LoRaWAN. So we can deploy our LoRa nodes. It can be like hundreds of temperatures and humidity sensors along with air quality sensors and other CO2 sensors. They can be deployed. And now we can place the LoRaWAN gateway. And this from with this gateway, we can get our dashboard. Like here, you can see a dashboard. So this is a typical architecture for deploying an environmental monitoring solution. Another one is very popular is like energy monitoring. So most of the energy monitoring is already happening. Some of them, but the problem is like we are not able to monitor on the individual nodes, like monitoring on a panel level or a machinery level, because that requires a lot of wiring. That will require a lot of wiring, lot of effort, and also we are not able to monitor remote location because that will again requires wiring, or it will require to cut to the 4G networks and then send data to cloud, then back to premises. So it will be a costly solution, and also it is a tedious process. But using LoRaWAN, we can like read all the meters, panel meters also. And where there is no panel meter or energy meter installed, we can simply install a the current sensing sensors and measure the current data. RS485 Modbus interface, we can get data from PLC drives, HMIs, panel meters. These are the connectivity where from we can get data. So this is a typical architecture of a energy monitoring solution where we have these panel meters which are connected to our LoRaWAN RS45 node, and they are talking via Modbus, and then it can send data to our LoRaWAN gateways, and then these gateways will send data to this LoRaWAN network server. So in a industry, we only need one LoRaWAN server, and there can be a gateway, multiple gateways, and we can deploy thousands of these sensors, and then we can have our EMS application and dashboard from where we can monitor all this parameters and energy consumption of our industry or a particular process. We can do flow metering, like water flow metering using our standard pulse output as our RS45 output sensors. We can do gas flow metering, contactless ultrasonic flow metering, which can be also done using LoRaWAN, and battery powered remote meter reading. Like some of the water sources or some of the sources are remote, like we are sending oil, water, or any liquid as a long distance, and we have multiple flow meters installed. So mostly and now we can monitor for on the each node, like we can monitor like how much water, groundwater level we are consuming, because now the government and the industries are more focusing towards sustainability, how they can reduce their utility resources. So remote monitoring of meters can be done via the wire, our battery powered sensors. We can just send data to LoRaWAN network, and here is the flow meter reading architecture. So like we can have different flow meters that can connect via RS45 or via pulse input. Then they can send data to LoRaWAN gateway, again the similar LoRaWAN network and application. And then we can send data to flow metering dashboards. And we can also do electrical and instrumentation panel metering. So here we can measure the temperature and temperature of the electrical instrumentation panel, because most of the time they are get neglected. Like what happens, mostly these devices have a tendency to overheat, some contact is going wrong, or maybe the temperature is getting rising and nobody notices. Or the most tedious way of doing is like getting a thermal imaging camera and scanning it, but it cannot be done on regular basis. So oftentimes these things are ignored, and the health of the equipment is degraded over a period of time. But with LoRaWAN, we can like put a small sensors on our bus bars on our panel, or in the panels also, and then we can monitor the temperature of the individual panels. Our electrical instrumentation panel, we can monitor the temperature, and then accordingly, if we see there is some uh, abnormal behavior of that panel, then we can go and inspect the thing, that what is causing the problem, and then we can fix it. So it will greatly reduce the downtimes for the industries due to the equipment failure. And now we can do the temperature monitoring of motors, gearbox, and machineries, oil temperature monitoring for various purposes like cutting, tooling machineries where the cutting oil is used, and in various other processes, oil is also used for different application. Boiler temperature monitoring can be done, and remote temperature monitoring can be done also. So we are already doing some applications regarding motor and cutting oil temperature monitoring in automotive industries, on the precision manufacturing industries, where we are monitoring temperature data from the motors and also cutting oil data. And this improves the like efficiency also, and this improves the downtime. Also, like when the oil get heated, the tools are more frequently breaking. So this is the architecture, like we can place our thermocouple node on our motors, and then we can get data to our LoRaWAN gateways. Then the gateway will send data to server, and then we can have the dashboard to monitor our motors health also, and when we need to do shutdown, when we need to do it, the maintenance, and these kind of things. And also we can do predictive maintenance, like vibration analysis of the critical assets can be done using LoRaWAN networks. Also, like we can place a sensor on the motor itself, and then it can send the critical data over a LoRaWAN network. Temperature monitoring can be also done because these sensor node already have a vibration sensor as well as a temperature sensor. So there are many solutions from Yokogawa, ABB, Emotion, who provide these LoRaWAN industrial vibration sensors. We can also monitor the critical parameter from the remote location. Let's say if I have a pump, a centrifugal pump running at a 1 kilometer distance from my current facility. So I can also monitor that data using LoRaWAN network. So we can also monitor our remote parameters using LoRaWAN network, and I can determine whether the health of that particular machine is good or not, or does it require some kind of maintenance. So UniConverge provides a complete LoRaWAN network solution. We provide LoRaWAN devices, we provide LoRaWAN gateways, LoRaWAN IoT platform, which combines our LoRaWAN network servers and the application server. And then we will have a dashboard and an analytics system named as UCT Insights. So here are some of our LoRaWAN products. And we also provide LoRaWAN expansion plugin modules. So any OEM or manufacturer can utilize these and make their own products also. So here are the some of the inputs and sensors we are currently supporting. We have DIDO to LoRaWAN communication sensor. We have pulse input to LoRaWAN end node. We have 4 to 20, 0 to 10 volt DC analog input LoRaWAN node. And then we have a thermocouple to LoRaWAN converters for interfacing thermocouple, whether it can be J, K type thermocouples can be easily interfaced. Uh, and we can send temperature data. Then we have RS-485 to LoRaWAN converters, which can send take data from RS-485 and can send to LoRaWAN network. We also provide temperature and humidity monitoring, a LoRaWAN node, which we can deploy. They are both battery powered as well mains powered, so you can deploy and measure temperature, humidity, or individually temperature also. Then we are also working on vibration sensors. We are designing our own vibration sensors for LoRaWAN applications, which can be easily mounted on a motor or any asset, and can give us the valuable vibration data. We also give the LoRaWAN gateway, which is 8 channel, and the power is like 27 dBm, and it has all the Ethernet 4G Wi-Fi backhaul. So you can connect it with Ethernet, 4G Wi-Fi, and you can send data to LoRaWAN network. And then we have the IoT platform. So LoRaWAN IoT platform, we provide both cloud solution as well as an in-premises solution. And here we provide a complete LoRaWAN network server that can be deployed and easily on the cloud also, and on the user device also, and that have all the backend integration and APIs that are exposed uh, to users, so they can develop their own applications. And it has a good support for MQTT, REST API, WebSocket, and also AWS integration. And then we have our industrial IoT platform, which is UCT inside, which have these features like telemetry, data collection, data visualization, IoT rule engine, alarm management, device management, and then we have a security system with a web tokens, AES encryptions, and then it has customization and integration with all the other third party tools, like it can support Grafana, AWS, Microsoft Azure. These can be done. And also it has support for the SQL and NoSQL and hybrid databases. Along with this is a very fault tolerant system, so everything works separately. So once the system, if any of the module fail, it won't interfere with the another module. So this we also provide this UCT inside on a both manner, like it is also provided on the cloud based also, and it can be also deployed on your in premises. And now we have some of our proprietary LoRaWAN networks, LoRaWAN M2M products like wireless IOS 4DIDO transistor, from where you can send one data to another and basically replace the whole wire. And then again, RS-485 to LoRaWAN converter. So this is the architecture of our own proprietary LoRaWAN converter, from which you can send data from one to another. Now, here are some of the example of our projects that we are doing or done, and then we can move to the Q&A session. Okay. So here are some of the solution that we've done. Like we have done like 158 kilometers of a LoRaWAN network deployment on a ORR Hyderabad drip irrigation project done by us, which is involved 600 irrigation valves. Like 600 solenoid valve are controlled by our LoRa nodes, and we are controlling over 50 motors along with the parameter monitoring of the flow meters, pressure sensor, high level, low level sensors, rain sensors, rain sensors, and uh, also we are getting data from feedback data from the motor starters. And it have a 4G backhaul to control room. And irrigation can be done via time based system, where we can set a time, like okay, we have to irrigate this wall for 1 hour, or we can also do a volumetric irrigation, where we want, like okay, I have to put 20 kiloliters water on one valve. Each valve should have 20 kiloliters, or I have a total of 100 kiloliters of water that can be can be irrigation over a month or week or a day. And then we have a report generation modules, leak detection, whether we have some kind of leakage or pipeline failures, and water consumption analysis. So this is the typical architecture, where we have our 4G gateway, backhaul gateway, LoRaWAN 4G backhaul gateway, which is also sensing these data from the pump, flow meter, pressure sensor, rain sensor, level sensor. Then it is sending data to HMDA office, where we deployed our gateway. and this whole system is now managed on AWS. And here are our remote units which are controlling the walls, and they are using LoRaWAN network. And here are some of the images from a project site. So this one is solar powered LoRaWAN node which is controlling the wall, and here is our whole system which is deployed with a battery backup, rain controllers, motor controllers, and along with our 4G gateway, LoRaWAN 4G gateway. And this is the image from the office of the HMDA Hyderabad office. And here you can see, like, we have getting all the data of the whether pump is on, what is flow rate, what is the water pressure, whether the tank is full, half full, or it is empty, or whether the pump is started to fill, and now what valves are running, and which is completed and which are now next in the schedule. We can get all these data. We can uh, like control these valves individually also, like you can set a schedule and this will work automatically again. And the next project we done is like a tank level and flow meter reading for IOCL. We are metering the ethanol tanks for flow sensing, and also the tank level for the ethanol tank. Here we implemented a more of a point-to-point approach on a trial basis, where we are taking data from flow meter and a radar sensor, and then sending to LoRa converter, LoRa RS45 converter. Then we are sending data to a dashboard using our again LoRa RS45 converter. So basically, here we are just uh, uh, like eliminating the wiring that need to be done. Like a 1 kilometer of wiring is being removed with this setup. This is the image of our device enclosed in flame-proof enclosures that is deployed in IOCL. And then we have temperature humidity monitoring solution for aerospace wire manufacturing company. And here you can see we have deployed these sensors. Uh, and this is the dashboard, and it is deployed in the mixing room of the insulation of that wire coating sensor, and then it is integrated to their ERP system for their compliances. So now we can move to our Q&A, and we can take questions. And so, like, how this is a simple question from my side, like how LoRaWAN can help in your digital transfer, like for your industry, how you can implement LoRaWAN. So I will take questions also, and I want idea from your side, like for my presentation, how you understand LoRaWAN and how you can give us idea that what LoRaWAN can, like how you can implement LoRaWAN on in your industry to solve your particular problems. Okay, so I have one question. Like we have some questions. The first question is like, how can we connect normal temperature sensors to LoRaWAN gateway? Okay, so normal temperature sensors, when I say, whether it can be a RTD, it can be a thermocouple, these kind of sensors, we can just place a LoRaWAN node there, and we can connect these sensors to a LoRaWAN node. Like we can connect these sensors to RTD to thermocouple converters. There are available in market, where you can get uh, these temperature sensors converted, and then it can be send data to LoRaWAN gateway. So we also have a thermocouple to a LoRaWAN converter, RTD to LoRaWAN converter, and also for if the sensor is 4 to 20 milliampere, then we also have 4 to 20 milliamps to LoRaWAN converter. in the next question is, can we connect home energy meter to LoRaWAN gateway for remote monitoring? Which component do we need for that? Okay, so for energy monitoring, if we are doing it for only one, if for home purposes, if the uh, place you are living already have a LoRaWAN network, first of all, because if it doesn't have a LoRaWAN network, then you have to first deploy a LoRaWAN gateway. But yes, if you want to manage more than 1 meter, like for 1 meter, LoRaWAN is not a right solution to go if you don't have a public network. But if you have multiple meters, then you can just deploy a RS-485 to LoRaWAN converter, and then you can just send data from your home energy meter to LoRaWAN network. And we also have a DLMS to N LoRaWAN converter that are used for standard utility meter that are installed in our households. So if my explanations are, if you are not convinced with the explanation and if you have more questions, you can ask again. So the another question I have, how do we send the data to cloud from LoRaWAN gateway? Okay, we send data from LoRaWAN gateway to cloud using MQTT, HTTP, UDP, these kind of protocols, and over the backhaul of 4G, Wi-Fi, Ethernet. We can have a standard uh, uh, networks, and then from there we can send data to cloud, and where we will have our LoRa network server. Let's say if our LoRa network server is not on the cloud, so now we have to connect our LoRa network server to cloud. LoRa, there also it has the standard integration for AWS, Microsoft Azure, ThingsBoard, ThingsP, and all the major leading providers. The LoRaWAN network already server already has support for that. Okay, so no, we don't. Right now, we are operating from Noida itself. We don't have any representation in Pune city, but yes, we can connect with you. What are different type of vibration measuring sensors? So, vibration measuring sensors are like, they are a lot in based on your need. Like some of them currently the industry is using more of a not of continuous measuring interface. They are like putting a vibrometer and then sensing data, and then they remove the sensor. But now some of the big players and big industries are now deploying uh, LoRaWAN sensors or vibration sensors on the machine itself, and then they continuous monitoring it. So they are battery powered sensors, and the major companies are like ABB, Yokogawa, Immersion, and Advantech. Yes, 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 sir. Okay, which server is used? So for which application? Like um, for a LoRaWAN network, we can also deploy it on a standard server, and we can also deploy it in on cloud also. Like a standard server or standard industrial grade server can be used, or a commercial server can be used to deploy LoRaWAN network server and applications also in premises. If we want to make deploy it on a cloud also, then a standard EC2 instance or a compute instance on a Google Cloud, AWS Cloud, or any Microsoft Azure Cloud can work. Yes, a LoRa, can a LoRa WAN be set up in any location all across India? Yes, it can be set like all across India. And you can set up a LoRaWAN network. It completely in a ISM band, and you can just put a gateway, and then you have to connect to a network server, and you can install your own network server. If you install your own network server, it will be a private network, and if you want to make it for public, then you have to connect it to some of the public network providers like Actility or TTN. Yes, yes, Gurmeet, sir. So, okay. I'm interested in UCT LoRaWAN. Please provide the. Yes, our team will definitely contact you, sir. Okay, how can we connect LoRa with our Wi-Fi router? So LoRa and Wi-Fi are two different technologies. Wi-Fi work on 2.4 gigahertz and 5 gigahertz. LoRa work on um, more of a 868 or sub gigahertz range. So they are two different technology. Yes, but if you have a LoRaWAN gateway which connects to Wi-Fi router, then you can connect a LoRaWAN devices to not to the LoRaWAN gateway. Then from LoRaWAN gateway, it will connected to your Wi-Fi router. And how many maximum devices can connected with LoRaWAN? So a single gateway is enough capable of connecting like on theory it can connect like thousands of devices or even more. But practically 4 to 500 devices is a very much acceptable in industrial conditions. Okay, so how to deploy own LoRaWAN gateway on chipstack and receive data from multiple end nodes? So, sir, you can do it like you can just connect your LoRaWAN gateway and you just install a chipstack or use their service, and then you just put register you have to just put the IP of that chipstack server into the gateway, and then on the chip stack you have to register your gateway using the EUID, and then it will be connected to your chip stack server. And after connecting to this LoRaWAN gateway, then you have to individually register your nodes. So you have to make an application first, then you can in the application you can uh, register your end nodes. So what are the restrictions of a LoRaWAN setups? So the restrictions are like you cannot send a very huge amount of data. First restriction is that this only. Second restriction is you cannot see the very high speed data. Like you cannot doing a transmission every second, like every millisecond or every hundred of millisecond. It can be in a certain guideline, which is the set by the LoRaWAN Alliance, and it is governed by the LoRaWAN regional parameters. So we have to check our regional parameters, like what are the duty cycles and the channels that are provided in the regional parameters. Like for India, we have different parameters. For Europe, we have different parameters, and for other countries, we have different parameters. So the only downside of the LoRaWAN is like we cannot stream a huge amount of data at a very fast rate. Which entity, public and private, deploys LoRaWAN? So there are major players who are deploying public LoRaWAN networks. Some of them major are like Tata, Actility. They are deploying their solution in India also. And private network, they are like you can set up your own private networks, and you can hire some of LoRaWAN deployment companies like us or some other like Advantech. They can set up a LoRaWAN network for you. Yes, if you use the in-house service, it will be free, but you need to understand that how you will set up a LoRaWAN server, and you can set up your own. Can we use these module with wired sensor or it required wireless sensor? No, the end node will require a not require a wireless sensor, because we can connect our traditional sensors. Like if we have any sensor which sends a digital data like a 0 1 format, either it can send data in analog format, which is our traditional industrial sensors 4 to 20 and 0 to 10 volt sensors, 4 to 20 milliamp, 0 to 10 volt sensors. And we can also connect sensors from ranging from millivolt sensors to thermocouples RTD. So we can place a node which can collect data from the wired sensors and can send data to LoRaWAN network. So we already have these products, like we have eight AI LoRaWAN node which can connect eight wired 4 to 20 sensors and can send data to LoRaWAN network. Are your products suitable for low cost IoT solution for small manufacturing companies? Yes, definitely. Our products are very much cost effective and very great value. It provides for small manufacturing companies, and even we are working with some of the small manufacturing companies already, and we are providing them solution like their temperature monitoring, their machine health monitoring, their process count, counting their overall process and efficiency along with their energy management. So we are providing uh, very cost effective solutions. Okay, so if any of you have any other questions, you can just ask. So I think one raised hand I see. Uh, Gurmeet sir, if you have any query, you can ask. So is there any question or shall we conclude the this webinar? Okay, so I think there are no more questions. So we are concluding this webinar, and thank you for thank you for participating. Um, we will be conducting more of these seminars like webinars. Today, agenda was like industrial IoT, and later we also provide solutions or smart cities, smart irrigation. So we will be covering more of these topic in our upcoming webinars. So, if you join our, uh, we request you to join our webinars. So, getting more information regarding these Industry 4.0, smart industries, smart city, these trending technologies and upcoming technologies, and also we you can enhance your knowledge. So, thank you, everyone.
The webinar has ended. Thank you for joining. Goodbye.